Another coffee session is underway. This is a very special one. I've got my cup of gratitude. I don't know if you all can see that, if it's in focus or not, because today we are going to be talking war stories and a few other themes with none other than Nick Masca. And Nick, the way that this came about, I think we should talk a little bit about how you ended up on here with us today. Oh yeah, and by the way, we've got Vishnu, none other than Vishnu, my
Hello,
main
hello.
man. What's going on? So the way that this happened is I asked on LinkedIn for war stories. I said, what was some crazy war stories that you've had while trying to do anything related to MLOps? And Nick's story, I think, took the cake. There were some great stories on that LinkedIn post, and I'll try to link the post down below in case anybody wants to read all the posts because there are some incredible stories. But Nick, your story took the cake. And so I want to talk about that. I also want to talk about some of these problems that you've encountered while deploying models and other war stories that you've accumulated over time, because I'm sure that wasn't the only one. But before we get into
Fantastic.
that, it might be useful for the audience to hear where you're coming from, how you got into tech, what's your background?
Sure. So yeah, thanks for the introduction, and yeah, thanks so much for having me on here. And you just showed your mug of gratitude a second ago, but myself and others in the community, we all owe you a lot of gratitude for building up this community. I think the Slack group I
You're too
absolutely love.
kind.
It's a huge fountain of knowledge on all things like ML and ML ops, and it's a fantastic place to get advice from people uh, around deploying machine learning, which is has many troubles, many risks, and yeah, looking forward to sharing with you some of my learnings that I've picked up over the years.
Mm.
So I guess, yeah, to introduce myself, yeah, I'm Nick. I currently head of data science at Marks and Spencer's in the UK. We're a large kind of traditional retailer in the UK. I think we've been operating around 120 years. In my career so far, I originally trained as a statistician. My PhD was in genetic epidemiology, which at the time, if I told people I studied epidemiology, no one would have a clue what that meant. And now it seems like every next person you meet on the street is a kind of amateur epidemiology enthusiast. So yeah, my first few roles after my PhD were kind of in biomedical research. I worked in academia and in industry, in an R&D environment, kind of planning experiments and lab studies, and analyzing the results from those. And I kind of transitioned into data science after that. First in an analytics role in a financial services company, and I'll be telling you a bit about some of my struggles in that role and the pain and nightmares I still experience arising from these struggles. From that, yeah. This was a good few years ago now, in the early days of data science, and I think at that time there was a famous kind of Venn diagram to explain kind of what data science is, and I think it's evolved a bit over time, but I'm sure you will have seen it, and hopefully many of your listeners will as well. But they describe data science as being a combination of kind of math and stats, domain knowledge, and then hacking skills. And I think I
know exactly the one you're talking about. Exactly.
I got the opportunity. I certainly had some hacking skills, and my background was in math or stats, and picked up domain knowledge along the way. But I think these days, I think programming and sound engineering skills, I think we realize they're much more important these days. But in those early days, I think they were less known and less valued in the field. Perhaps some of the issues I faced early on we may have avoided through having more robust, more mature engineering knowledge and skills.
So tell us, did you go directly into the current job you're at? And just as a little side note, I love that you said, oh yeah, we've just been around for like 120 years. That's like coming from the US. That is a very long time, but over here in Europe, it's like, yeah, it's not that long.
Table stakes.
Yeah. Sure. Yeah, here's insurers have been around for hundreds of years, but yeah, we're not quite that old, but yeah, we're quite a traditional company. Yeah, it's an interesting time at Marks and Spencer's actually. We're in a department charged with kind of digitally transforming the business. We're traditionally a fairly siloed organization. Traditionally, we've outsourced a lot of tech and used a lot of agencies. It's interesting times because we're beginning to bring a lot of things in-house, which actually gives us quite a clean slate to work from. And as data scientists, like sometimes doing relatively basic things that you'd expect a mature organization to have had in place for years. Like we're getting to build some basics, some foundations, and having really big impact from some of the work we're doing as well. So it's quite exciting times here, lots of opportunities.
Maybe we can jump into that real fast. Like the building the basics, how does that work out? Like, are you focusing on the highest priority problems first, or is it just the low-hanging fruit? How does that look?
Yeah, it's a great question. I think early on, I'm kind of focused on delivering value, gaining trust through gaining some early wins. But we have kind of a 3-year plan where we're thinking of a bigger picture, around how we can automate at scale, much bigger systems. So we're kind of starting small, thinking big, and delivering value on the way. I think when I've only been at M&S 6 months or so, I think I was quite fortunate to join with a very tight deadline when I first joined. A model that had kind of been in R&D stage for about 9 months. When I joined, had built up really quite a lot of complexity and technical debt there. The team I joined to lead had been faced with a deadline to finally productionize that within about 2 weeks of me joining. Those first 2 weeks were quite frantic as I desperately tried to establish what that path to production for this algorithm was. But that was a fantastic learning experience to actually get something out in front of customers so early, and it turned out to be quite impactful. I think we faced a lot of pain along the way, and talking of war stories, I could rant probably about some of the pain from that, but perhaps I could save that for later or another day. But yeah, we've seen huge improvements as well. I think it's word of advice. If you can gain trust and demonstrate value early, then it often frees you up to do more exciting things later. And we've been able to pay back down a lot of technical debt recently, establish some much stronger foundations that allow us to build and iterate rapidly now from a more solid code base, while still scaling out an algorithm and delivering value.
Got it. Yeah, it's interesting that you mentioned the 3-year strategy and kind of how you bring these these changes to large organizations. Something like Marks and Spencer that's been around for so long, iconic brand. It's something I think in our community a lot of people would resonate with. A lot of people working at larger companies where they're saying, we have this ML stuff in place. Somebody told us to do MLOps. Now we kind of have to make it happen. So I guess going from there, this strategy that's in place, did you have an opportunity to write it, or is it something that was already in place? And can you tell us a little bit about what it's like to work and map your work to such a sort of like a long running vision?
Sure. So yeah, I could tell you around about 2 types of vision we've had. We've kind of got our kind of business goals and our business vision around the types of capabilities that we're looking to build that we believe are going to deliver value. And then we've also formed an initiative built around implementing MLOps best practices. And we have a vision there and are making good progress around that as well. And that's, I guess the principles behind that are not necessarily to directly deliver kind of business or customer value, but we've set a number of like KPIs that we believe are really important, outcomes that we really need to deliver to kind of enable our data scientists to own the services they build, to deploy to production themselves without having to hand off to other teams, and to really speed up their workflow. I think historically, there's kind of legacy waterfall processes in the business where teams have very specialist responsibilities, and you have to you get requirements from one team, you do something, you hand off to another team, they hand off to another, and so many teams are involved, and no individual team is kind of accountable or responsible for the whole end-to-end process. You get delays, you have to synchronize and try and communicate and align with all those different teams, which adds risk. And that's like the antithesis probably of MLOps, having that kind of structure in place. So, one of our longer term strategies is working out how to break that down and empower our people and enable us to work at pace.
Some of these like KPIs that you're talking about, can you go through what those are? Is it like just
sure.
downtime? Or, talk us through that.
So we got a bunch of KPIs, some of which have been informed, inspired by the book Accelerate. I don't know whether you guys would have read that. So it's a book. Really, it's about DevOps. It tries to establish. It attempts to establish a causal relationship between kind of DevOps maturity in organizations and the success of those businesses, and via various kind of research and statistical analysis, the authors there have kind of proven that the more deployments a team can make, the faster they can get code into production, the faster they can repair errors when they happen. That there's a direct and strong correlation with the success of those businesses. So that's a fantastic book. I recommend that to anyone who's not come across that yet. There's many similarities there between that kind of DevOps culture and the aims of MLOps.
Got it. And so the actual KPIs that you established, I mean, how do those translate into like an action plan, right? I think that's always where I struggle. So at my company, I'm in charge of this MLOps stuff, right? And I think we hear a lot of interesting things like continuous training or pipelines or whatever feature stores, right? But how those concepts and how those popular ideas turn into real action that means something for your company, I always struggle with that. And I like your framework that you proposed of like, small wins to gain trust and to, put in place the structure to do interesting things in the long term. But I'm wondering how do you manage that process of going from KPI to action, so like strategy to tactics,
Sure. Yeah. There's a saying that kind of you are what you measure. So I think actually you just actually measuring some KPIs can be quite powerful at influencing behavior. So let me give you some examples of some of the KPIs that we're working towards impacting on this initiative. So one is reducing the time it takes us from committing code to having that code running in production. We have a KPI around reducing the number of manual steps taken to get code running in production, and we mapped that out, and our baseline was around 8 steps in the productionization process to begin with. I think we've reduced that down by about half now. Our goal is to reduce that down to probably 1 step. We submit a pull request, someone reviews it, and hopefully approves, and we think that should be the only manual step eventually in our productionization process. There's things like mean time to recover from failures. Many different ways you can action that. So some of it isn't necessarily technical. Some of it is around process. We have an ops team at M&S who are responsible for deploying to production. In the past, they would only deploy 2 days a week. we've managed to get them down to doing a daily deploy now, and yeah, as we decrease the number of manual steps in our productionization process, we're eventually aiming to lose that dependency on them, at least for like the majority of our deployments. So, yeah, another action is potentially like traffic lighting, the types of changes we make, so that low risk changes we can just deploy with minimal review, minimal sign off. Higher risk things, perhaps the ops team might want to do some testing themselves.
I love how you're taking also the idea that you said earlier about it was very confusing because so many teams were involved and nobody really had responsibility. And now you're trying to consolidate that so that it's very clear who has responsibility. I think that's important. And has it happened yet where the data scientists on your team are given handoffs and they have to monitor and make sure they have to be the ones that get the calls at 3 a.m. in case something goes rogue?
It's not happened yet. So I think we still have dependencies on the ops team who do that. But when things have happened and gone wrong at 3 a.m, it doesn't feel like an ideal solution having this dependency on ops. We might get a message at 3 a.m, but and this has happened in the past. We've looked into the code at 9 a.m. on a Saturday morning. We've worked out what's caused the problem by 9:30. We've pushed the fix by 10 a.m. on Saturday, but actually we can't deploy that fix. So we communicate as a team, but they're not working till Monday. That's it. Even if we send it to ops, they can't deploy it themselves either because it's an intermediate team. So so it ends up increasing that time to recover from failures like substantially. So we know that process is something we need to action, we need to overcome if we're ever going to realize that our ambition for reducing the time it takes to recover from failures to hours, not days, and reduce to minimize the manual steps in the productionization process.
Let's get into what we've all been waiting for, what we came here for. I think you should tell us the story you put on LinkedIn first, and then we'll get into a few more of the good ones that you have. But talk to me about what happened there. Was it at your current job? Was it?
No.
Okay.
No. So to set some context, and I still have nightmares about this occasionally. So my team and I, this is probably 2015. We were very excited to deploy a new algorithm to production. It was it needed to score in near real time. We developed a fantastic model, what we thought was a fantastic model. We were leveraging well over 100 features, had several thousand parameters, I think, in the model. Performed fantastic. We'd made our business case to all our stakeholders around how valuable it was going to be compared with what we were previously doing. And then every time, we deployed it at like a very small amount of traffic initially, but when it came to monitoring our metrics, like hang on a sec, it's just not having the impact that we expect. We really, and then that's when we just uncovered more and more issues and problems in our processes, problems in our code, problems with the data. Every issue we found, it seemed to set us back, several weeks to try and identify what was causing it, and then we couldn't get feedback until we launched a new experiment, and then we'd uncover another handful of problems, and it was painful.
Because everything was working okay when it was in staging, and then when you pushed it to prod was when it would start to go off the rails. This algorithm was built from data, in our databases, and we had quite clean databases that could be used for analytics and could actually be used by statisticians and actuaries to kind of build simple statistical models.
what we didn't realize actually that the data that we were using, there were a lot of transformations and formatting changes in that data set. Really, with the intention of cleaning it up to make it easier to consume and analyze and report on. The production environment didn't replicate those transformations. Something else we learned later down the line was the way we deployed this algorithm. We were basically generating code so that we could kind of translate our algorithm to run in this platform that we kind of ran pricing models through. But we didn't realize there were another bunch of transformations that were done prior to any data entering that platform. And again, most of these were undocumented. In fact, none of the other pricing teams were aware of these transformations, and many of the pricing models were not working properly and had been that way for several years because no one had really looked at the impact of these or understood the impact of, if we change a missing value from 0 to -1, that shouldn't have any impact, should it? But actually, that can. If you're modeling a continuous variable, that actually can cause changes to the predictions that an algorithm makes. So, yeah, there were many issues like that around transformations. No, any one team really understanding the full process or owning the process.
And I love how this is 2015. So it's like before there's even a term MLOps.
Yeah, absolutely. And yeah, I guess it's around about the time some of those papers from D. Scully and his team were starting to come out, but it was certainly before I'd seen those papers. And I know that was a fantastic interview you did recently, by the way. I thoroughly enjoyed that with session with D. Scully.
He's amazing. He's a legend.
He set the standards for us, really, and it's fantastic. The way he's described some of the issues and the quality standards we should aspire to achieve, I think, in ML. But this was way before I'd seen those papers. And,
I think those papers are great, and I think to me it's like the hard part, I think, with papers like that or just resources like that is, not everyone will have read them. We're both of us and all three of us, right? We're sitting in a highly niche Slack of people that are very engaged in our field, and we know, when people say, "Oh, high interest credit card at technical debt," "Oh, D. Scully's paper, that's awesome." Yeah, of course I've read it. And at work, I find that maybe not everybody has read that, and I think the challenge I find is, how do you communicate as ideas, and how do you get across to people that this is important to do, not just because people do it at Google, but because this is important to us. Like, how do you go about making that case in wherever opportunities you've been, maybe in that war story scenario?
It's a great question. I think one of the great things that team have gotten across is it's a way of kind of establishing best practices. That we can aspire to. I think they point out some of the problems that can occur, and I've certainly experienced some of the problems that could occur if you don't do some of those steps. I should say, going back to KPIs, actually, we have a KPI to kind of achieve, from the test rubric, the ML maturity test score paper. We've set a KPI against that actually as well. And there's lots of actionable steps in that paper around how to achieve higher scores and greater maturity. I think it's a great question, because articulating why something is important is just crucial. If you want to bring people on a journey with you, that is, if you can't get across why something is important, then you're not going to get far. There's no easy answer to that. Some concepts are easier to explain than others. I talked a bit about the Accelerate book. I think that's really helpful for making a case for why kind of DevOps and MLOps it can be valuable, by enabling teams to work faster, some of the issues we've had about reliability and things like that, if you've got jobs that are failing every other night, then that it kind of makes its own case for why you might need better standards.
Yeah, absolutely. I think the interesting thing about, kind of switching gears and going back to your war story, as Demetrius mentioned, it's 2015, all these concepts are very new. And, I think in some ways though, and this is something we talked about with D. Scully, right? The tooling and how you get, all of these things to play nice together always poses a challenge. And, I bet in 2015, I mean, you guys were probably using maybe an early version of TensorFlow or something, maybe, or even what frameworks were you guys using to do model development?
So yeah, we weren't using TensorFlow. We were to be honest, we were largely using R-based tools back in those days. Now that's quite a rarity. So we were using we use a library called H2O, which actually is still around. It's still quite a nice tool.
Yeah, H2O.ai, right?
Well. Yeah. So we were using that, but as I say, we're actually generating code from R that could speak the language of our pricing platform, so that we could translate these steps. And we built this beautiful system where you could type all your feature engineering steps in a spreadsheet. You can list all your fields, all the values.
Wow, that is really, really creative.
Convert all our code into this other language, and yeah, naturally there were bugs in the code, and then that set us back a bit. Maybe not as many bugs as you might expect. something that complex to present, but yeah, certainly bugs in the code were one of the many factors and pain points we experienced on that journey.
Yeah, completely. I mean, honestly, it's not surprising to hear you say R, right? Because it still is a lingua franca of data analysis. Like, a lot of people still use it. It's a great language. It's got a lot of tools and everything. For any kind of statistical method, you can find something in R, and that's really useful. But I still find this problem today of trying to get different tools to play well together, and how that confusion can make your process more convoluted. It feel like, it makes me a lot more gun shy to try and get myself involved into all these tools, because I know that, if something changes or if some, standard changes or whatever, then my process gets a lot more complicated.
Absolutely. Yeah, I hear what you're saying. And, we're going through some of these considerations here at M&S at the moment around, what tools we should be bringing in. And, do we want kind of a end-to-end platform, or is it safer to use kind of small tools that do one job and do that job well? These are conversations we're having at the moment. That there's a plethora of MLOps tools that are coming out at the moment, and there seems to be a new tool every day.
Yeah.
So I made a meme about it on the Slack group recently.
Yeah.
Cool.
Exactly. So this story is incredible, and I want to know, what are some of your biggest takeaways? What did you learn from that experience that you're not going to repeat, and you would encourage others not to learn the hard way?
Yeah, I think the most important learning for me that's really been very influential throughout my career and ever since is just the importance of starting small, actually getting something to working end to end, before trying to improve it. Having a model that had hundreds of features in it was so difficult to debug, and there were many of these features were correlated with each other. It was incredibly difficult to identify the causal problem when there were kind of data issues there. We had data issues as well, where some of the fields in the online journey were not populated when we expected them to be, and very, very difficult localizing that. Our audited data, everything looked okay, but the model wasn't scoring as we expected, and we had to get data in different stages of the journey to prove that. If we'd started with a small model with one or two features or a handful of features at once, it would have been much quicker to localize those issues, and we would have uncovered a hell of a lot of learnings about our systems. We could have started fixing those before scaling. and usually there's diminishing returns, right? You could probably get 80% of the performance from a model from using a handful of features, versus adding another 100 or whatever.
Yeah, such a great point. And we hear that reflected quite a bit. It's something that is so important and so easy to forget.
Yeah.
Because, and I think, Vishnu, we were just talking about this last week, right? Like, it's, as engineers, it's easy to start going deep down the rabbit hole. And then you realize, wait a minute, like you said, just get that 80% first. Let's debug it. And then let's make it like the Mac Daddy. Before we get there, though, let's just, start small and build up. So maybe we can transition now into some of the problems that you've faced while trying to deploy models. I know that was something else that you mentioned you wanted to talk about, and you have a bit of experience around. So I imagine you're no longer working with R. You've transitioned, right? So tell us a bit about what you've got going on now, and what are some of these obstacles that you've found while trying to deploy?
Sure. I'd say many of the obstacles you could almost relate to the same type of causal mechanism, not starting small enough, but being too ambitious too soon. I've seen probably over the last couple of years, some of the big pain points I've seen, either in my team or colleagues that I've worked with. I've been working with big data sets, crunching or operating big data pipelines. The more data you're handling, the more tends to be, even if you've got a nice Spark cluster that can handle it, the more data you're managing, usually the more complex and the higher risk and the workflow becomes, and the longer it takes to run. It can be more difficult to test end to end. I think, to give you one example, the team I joined now, one algorithm they had to process a table that with about 1 trillion records in it, and was going through many different data engineering steps on that table. It was hugely computationally expensive. 1 trillion records, and there were many data transformations, feature engineering steps being taken on that data set. One of the, our data pipeline was taking like 10 to 12 hours to complete, and there was only a 12-hour or 13-hour window for it to complete as well. So we couldn't really get much more. There wasn't much leeway there, and if it failed, there's basically no way of recovering that in time for the deadline in the morning. One of the things I encouraged the team to look at, and we found, was actually we could have used 1% of the data we were using and basically got the same predicted performance, or we would less than 1% drop off in predicted performance. So the number of rows we were using had very, very marginal impact on the performance of the model. Something else we discovered further down the line was actually most of the features had marginal impacts as well. We could have got a lot of the accuracy through a very small number of features. There was waste there, added complexity, added time, added effort.
I completely see what you're saying there. I actually think that one of the big areas and one of the big needs in machine learning tooling right now is around this sort of efficiency, not just from a model size standpoint or a parameter standpoint, but almost from like a mapping standpoint, right? Where we're always trying to map some input to some output, right? And what parts of that input are actually leading to the output? To do that, or to understand that, takes so much effort on the part of every practitioner, and it ultimately reduces the time to deployment. It takes the time, reduces time to production, or sorry, increases. I don't know why I said reduces, increases, and I think in our case, for example, we're in a healthcare setting, and we need to evaluate every single feature's impact on the model, the robustness of that feature over a large group of demographic
Right.
groups, etc. I would really love to see more tooling along those lines that help you understand how can you simplify what goes into your model and that kind of workflow.
Yeah, that sounds like a fantastic idea, and yeah,
I know
it certainly would be valuable. And I think there's some ideas, in the ML test score paper, around whether it's manual or automated, but testing how many features you actually need in that model, only deploying what's needed, and perhaps that relates to your point there.
And as far as like deploying, you had a bit of trouble around that. Like you realized, hey, there is something that we could do to make this much better, and we won't have to be working against the clock. But when you packaged that model up and deployed it, I imagine it wasn't all gravy. Like, how did that go, and what were some obstacles that you encountered?
Yeah, so let me think. There are things that I've already mentioned around kind of team structures that hampered progress. I think one of the manual steps in the deployment process was, we had to package up our model to run in a different environment, and then that would be packaged up and run in a third environment. That created risk. It tied us into a process where every time we wanted to make a change, we had to fill in this form, which would be read by another team.
Oh, wow.
And then they'd go through and implement each part bit by bit. And naturally, that was a horrible manual step, and we had several failures off the back of just human error, where either the form was filled in incorrectly or it was read incorrectly, and that process is just setting teams up for failure, right? So that's not necessarily a technical issue, but it's a process that makes operating machine learning difficult and risky.
That's a fascinating point. It wasn't necessarily the act of putting it into production. It was the process that you had around the act and how difficult that was. And so trying to streamline that process is ultimately where you see the biggest gains. And simplify, what it sounds like is you are coming in now and you're saying, hey, let's simplify things so that we can have more visibility and more understanding when it comes to this deployment. So how do you go about going from 3 different environments to, are you just going to streamline it into one? And how does that look? Like, how do you take all of these different places that you're doing things in and then just choose one?
Sure. Yeah, it's a good question. So we've been working on a better kind of environment now for data scientists, and I think we've negotiated and agreed kind of permissions now to kind of enable our teams to deploy to pre-production now, which kind of skips one of the steps in that process that we previously had to tackle. And then we still have someone in the ops team who would have to approve a request to get that running in production. But it's a bit more streamlined. We've got some better CI/CD processes in place. Probably fairly bare bones at the moment are the tests and things that we run there. But we need to improve that, work on that over time. But we hope that's going to help us de-risk things. Again, there are, going back to processes, actually having written standards can be quite helpful, whether that's, data engineering kind of standard. So if we want to write data into our data lake, which our data team has ownership and responsibility around that, we're trying to work with them at the moment around getting them to define the standards that are needed for them to accept like our logs and things like that into the data platform.
That's great.
Which previously would have had to schedule like 3 months in advance so that they would actually do that work for us. We're trying to document standards so that we can actually do most of the work ourselves, and it's just a case of getting a quick review and then approving our requests as long as we can meet their standards in future. I think I talked a bit about a traffic light system for deploys, agreeing those standards, documenting those standards around what teams can do themselves versus what will be a high risk thing and needs more scrutiny by other teams. I think a lot of game from work in process.
Yeah, absolutely. I think one of the things that you just triggered in my mind is I think I tend to work a lot solo because I'm actually the only machine learning engineer at my company, and it's a tricky position to be in. But
absolutely.
I think talking to you, I realize just asking teammates, what is it I'm missing? What do you think that you would add to this? Or just kind of, using that, I'm realizing how much teamwork is involved in what you do, right? And maybe that's an obvious thing for me to state, but I'm kind of curious, can you tell us a little bit more about the makeup of the team that you work with, what the experience levels are, like how you guys, interact and what that's like?
Sure. Yeah. It's a good question. And, I think our team structures are beginning to evolve. I think traditionally at M&S, we're fairly siloed. We have functional teams and this, even if teams are kind of claiming to kind of work and using agile methodologies, really it's just a bunch of kind of waterfall teams that have to hand off to each other. We start experimenting with having cross-functional kind of agile squads, mission-based teams, where we have engineers working with data scientists, data engineers, product people involved. We're still, we're still working out how to get that to work smoothly, because still like functional areas will have responsibility and ownership about different systems, and so there are permissions issues at times, sometimes political issues to negotiate. So that it's an evolution. It's not a revolution, I'd say, at the moment, but there's definitely a real emphasis where we are to improve things and work towards goals to enable our teams to work quicker, empower them, and I think having impact, have better impact that motivates many people, being able to see impact from their work, rather than working for months on end, having to hand off to a different team, and then eventually getting some political issue that prevents it ever getting signed off as well.
It's demoralizing. It's completely
Absolutely.
demoralizing. I could see that. And then you're stuck like, well, it's not my fault that it didn't go out, and you're pointing fingers, and that's not healthy for an organization, right? That's not healthy for the culture and the teams. There's tension between the teams. So I applaud you for trying to bring it to a more streamlined and more ownership on that. Now, we're kind of running out of time, and I wanted to get to, I think you've gave some incredible advice about making sure to start small and then iterate on that so that you can find the big problems first before you have so much complexity where you have to dig through the weeds for days or weeks to find these big problems. You've encountered quite a few other hiccups, and you have all these other war stories. Is there any takeaways that you would say are super important for us to look at that you've found from your other war stories?
I'd say, the biggest takeaway for me is, to start small, keep things simple, try things, and actually you can be surprised sometimes at what you find, and sometimes the surprise could be negative, but if it's negative, you can kill that off, and you've not spent much time. Other times it was, something we've just found in my team is actually we've got surprisingly positive results from something that we've built in a very lean way. You can actually get surprises in both directions, just by trying and actually getting some data and getting the results, and you can get them much quicker by starting small. You don't necessarily need to use state-of-the-art algorithms for everything. Something simple can give you surprising results.
That's a great one too. You don't need to use the top of the line or the state-of-the-art algorithms. And before we finish, I wanted to just ask what your opinions on this was, because I was talking to somebody a few days ago about how they see the whole field of data science and machine learning. They see like companies and the AutoML style stuff coming and taking parts of the business that don't necessarily get machine learning plugged into it, because the data science team is more focused on the important pieces or the higher ROI pieces. And that part of the business that is maybe a lead scoring algorithm, and the data science team doesn't necessarily look at that because they're too busy with fraud detection, and they don't have time to look at the lead scoring or do the lead scoring. And then you start to see that there's companies trying to democratize this other piece. So not the most difficult machine learning problems are being democratized. And I'm wondering if you feel like that is possible, if you feel like that is something that probably is not going to happen, or how you think about it. And let me know if I didn't make sense on that, because I'm still kind of trying to wrap my head around it. So if I didn't articulate myself, just tell me.
Yeah, so to paraphrase it, you want to hear my thoughts around, whether the kind of the simpler applications could be democratized or even commoditized,
exactly,
purely using off-the-shelf solutions.
Yeah.
It's a great question. I can certainly see some areas where they definitely could happen. And there are online tools these days that can run like multi-arm bandits off the shelf, and that could be really powerful on a website, which kind of makes you ask, why would you build that yourself now? And there are many big other tools like Salesforce that can do a lot of AI off the shelf, and often it would make sense to use that rather than build yourself. I think some of the areas in my current role where we see opportunities for building things ourselves rather than using off the shelf that we might have access to, is just to enable kind of consistent experiences across channels. So, for example, Salesforce might have some great AI that we could use in marketing, but then we can't use that. We can't create a consistent journey on the website because it simply can't run there or in other channels. So, handling different channels, I think, is going to be difficult. To have one tool that can do all that. Interacting with different data platforms and things could be tricky, but some of the cloud providers, for example, have a great head start and potentially a moat that they can continue to build around their products. There's many small operators in MLOps these days, right? But it also seems like the big cloud operators are continuously churning out tools as well that natively interact with their cloud platform. It's
totally.
How much they can expand those to take over regular data science, I don't know, but yeah, certainly seeing drop down menus and things like that I'm sure they'll keep adding features to those, and maybe more and more will become commoditized.
Yeah, it's just something it popped into my head, and so I appreciate your viewpoint on it, and also the idea of, again, it takes me back to what you were saying and how you had 3 different environments, and right now you're trying to consolidate into one, and you're talking about, well, yeah, maybe you can use some of the AI that's off the shelf from Salesforce, but it doesn't create that consistent user journey, which you value more. And so it makes complete sense. I think that's about it. This has been awesome, Nick. I really want to thank you for coming on here, sharing these war stories, and giving a little bit of practical advice to us, telling us about your journey, what you've been doing, how you have iterated, evolved, as you put it, in the MLOps space at your company. And yeah, Vishnu, you got anything else you want to throw in?
No, just thank you so much. I think a lot of people will resonate with your experience, working at a larger company, trying to fit into existing processes, but bring the latest and greatest in as well. And so I think it's been a great conversation.
Yeah, thanks very much for having me. Yeah, really enjoyed the conversation. And yeah, I hope some people can learn from some of my troubles and mistakes.
Yeah, so they don't have to repeat them and bang their head against the wall. I really think, yeah, you put it really, really clean when it's like, try things, but try things in a small manner so that you're able to fail fast or get those small wins and realize, should we bring on more complexity to this problem? So awesome. Thanks again, Nick. We'll see you later.
Thanks a lot. See you soon.